Hello students, welcome to the mole concept chapter. So let me begin the chapter with explaining what is the idea of the unit mole. Mole is basically a counting unit. So since long time ago, people have always grouped numbers into convenient counting units. For example, if we say one pair would mean two. So one pair of shoes is actually two shoes. How about a dozen? A dozen means that we have 12 of it. So a dozen eggs means that we have 12 eggs. So similarly in chemistry, we use mole as a counting unit. Why is that so? Because for atoms and molecules, they are so small, which means that there are many of atoms and molecules around. So it would be very inconvenient if we say there are like a million or a billion or a zillion of molecules around, right? So we use this mole to represent. 1 mole represents 6 times 10 to the power of 23 particles. Okay, so when we say there's 1 mole of, for example, neon atoms, which means that there are actually 6 times 10 to the power of 23 particles of neon atoms. Okay. Now let me just change these things to be copied in red, so it will be easier for you to know that all these things need to be copied. So what is this special number 6 times 10 to the power 23? Is actually known as the Avogadro constant. All right, so if 1 mole gives me 6 times 10 to the power 23 particles, this means that the number of mole is equals to number of particles divided by 6 times 10 to the power 23. Okay, let me write it down here so it will be easier for you to see. 1 mole is 6 times 10 to the power of 23 particles. Right? Okay, so if I want to find the number of moles, that would be the number of particles divided by 6 times 10 to the power of 23. Okay, or we can manipulate this equation around. Number of particles is simply the number of moles times the Avogadro constant. Okay, so if I have 1 mole, okay, so let's say, let me use a pen to write here. So if, let's say I have 1 mole, okay, then my number of particles will be 1 mole times 6 times 10 to the power 23, which will be 6 times 10 to the power 23 particles. If I have 2 moles of substance, then it will be 2 times 6 times 10 to the power 23 particles, right? And so on and so forth. Okay, now that we know what is a mole, let's move on to calculating what is a relative atomic mass. What is relative atomic mass? Okay, relative atomic mass, the definition is very important. Okay, let's put 3 stars, okay, and write down, must memorize. Now, there's not a lot of definition in chemistry that you need to memorize, but relative atomic mass, or known as AR, is one of the important definitions that exam like to test us. So please make sure that you memorize it. Okay, So what is it about? It's basically the mass of an atom, of an element. Okay, it's the average mass of an atom, of an element. Like when compared to 1/12 the mass of an atom carbon-12. So, like the word relative suggests, okay, it's a comparison. What do I mean by comparison? So, for example, let's say let's say I am 50 kg. Okay. Let's say my son, he is 25 kg. So, Miss Fong, I am how many times the weight of my son? So I am 2 times the weight. Do I say 2 times kg the weight? No, I don't, okay? Because this is a comparison. So I simply say I am 2 times or twice the weight of my son. Okay, so this is a comparison. Therefore, for a comparison, there will be no units. Okay, similarly, relative atomic mass is a comparison of the average mass of an atom of an element. So example, I can compare an element of oxygen, okay, when compared to carbon-12. So I compare the mass of the oxygen compared to mass of the carbon-12 atom. So how do we know the relative atomic mass figure? Okay, the number can be obtained from the periodic table. Okay, can we highlight? Now, which part of the periodic table? Okay, so when you look at the periodic table, there's actually 2 numbers. Okay, let me give you an example. Okay, we will have sodium, Na. Okay, we have a smaller number, 11, and a bigger number, 23. The smaller number refers to the number of protons. The bigger number refers to the number of protons and neutrons. Now recall that protons and neutrons, they both have masses. Therefore, when you want to obtain the relative atomic mass, you need to look at this number, the bigger number. Okay? So let me write down the values can be obtained from the periodic table. Which one is it? It's the bigger number. All right, let's do a quick practice. Okay, so using the sodium as an example that I've mentioned, is it 11 or is it 23? That gives us the AR. AR is the relative atomic mass. Okay, so as mentioned, the answer is the bigger number. So in this case, it's 23. Okay, let's go on to find nitrogen. Can you find nitrogen in the periodic table? Okay, let me pause here for a while for you to find nitrogen. Okay, very good if you can find nitrogen, which is in group 5 of the periodic table. Nitrogen has the value of 7 and 14. Okay, so which number do we take? Is it the 7 or is it the 14? We take the 14. Okay, it's the bigger number. Okay, carry on with the rest of the practice here, okay, from the periodic table. Okay, pause your video here to carry on the practice. Okay. Now let me continue. Let me give you the answer to helium, copper, iron. Let's check. Okay, do your corrections if you have gotten it wrongly. Okay. I believe most of you should be able to find all these numbers from a periodic table. It's the bigger number. It take quite long to find the elements from the periodic table. Okay, don't worry, practice makes perfect. All right, let's move on to relative molecular mass. The next page. Now, Relative molecular mass definition is over here. Okay, similar to the relative atomic mass. We gotta memorize. So let's put 3 stars. Remind us the importance of it. Now the definition is very similar. Okay, only a little bit changes, which is instead of atom, it is now molecule. So instead of animal compound, instead of just element, it's now element or compound. Instead of just an atom, it's now a molecule. Okay, so similarly, it's a comparison. There's no units. Now, how do we find the relative molecular mass? Simply we add up all the relative atomic masses of all the atoms in the formula. Okay, let me show you an example. Now, what's the formula of carbon dioxide? Okay, very good. If you remember, it's CO2, carbon dioxide. So how many carbon do I have? I have 1 carbon and 2 oxygen. Okay, so recall our relative atomic mass. We find the bigger number from the atomic from the periodic table. Okay, so for carbon, the bigger number is 12. Okay, plus I need to add up oxygen. How many oxygen do I have? I have 2 of it, and each oxygen has a relative atomic mass of 16. Okay, so when I add them up, it gives me 44. Now let me just repeat again. What is 12? 12 is carbon. What is 16? 16 is oxygen O. I have to multiply 2 because I have 2 oxygen in my formula. Let's try one more example together. Now, what is fluorine gas? Fluorine gas formula is F2. Okay, remember that is a group 7. Halogen is diatomic, so I have 2 atoms in the formula. So for fluorine, let's look at the periodic table. It's in group 7. It has a relative atomic mass of 19. Now remember that there are 2 atoms, so I have to multiply by 2, which gives me a 38 for the MR, molecular mass. Okay, I will pause here for a while, so please pause the video and continue the rest of the practice questions yourself. Now, if you need help with the formula, because if you notice that if you can't get the formula out, you cannot get the relative molecular mass out. If you need help with the formula, let me give you the formula now. Now, if you are confident, you want to try, please pause the video now so that you can try it out, the formula yourself. Okay, methane is CH4. Methane, you haven't learned before, so not to worry if you're not familiar. Sodium chloride is an ionic compound, so you have to use the crisscross method, which is the Na plus Cl minus. Do a crisscross, the formula is NaCl. Copper 2 sulfate, aluminum oxide is Al2O3, oxygen diatomic, ammonia NH3, zinc, remember, is 2 plus, so you have to do a bracket 2. Silver is Ag plus, iodide is I minus. Okay, give it a try and we will go through this in class. Okay, welcome back, students. Now that you know what is the idea of mole concept, you know how to calculate the relative atomic mass AR and the relative molecular mass MR. Now let's move on to other formulas of this chapter. So on your page 3, you can see that there's quite a lot of mole concept formula, but don't worry, let's do it one at a time. Let's focus on the first formula, okay, over here, which is the number of moles of substances. Okay, this is the first formula. Now, before we continue anything, let's put triple star to indicate the importance of this formula, which you gotta memorize all of them. Okay, so number of moles, let's memorize together now, is equals to the mass of substances divided by the AR or the MR. The AR and the MR is the atomic mass and the molecular mass, which can be found from the periodic table. Okay, it is the bigger number of the periodic table. Okay, let me write down a triangle here for you. Okay, M for the mass of the substance, N for number of moles, okay, AR or MR, which is from the periodic table. Now let's try some practice questions here using the formula. We want to calculate the mass or the number of moles of the given substance. So in the first question, we have 4.5 grams of ammonia gas. Now we see the unit gram, which means that this is a mass. So we are given mass by the question, which means that we need to find the number of moles. Let's write down the statement. Okay, in mole concept, it's important to write the statement. You may be penalized if this statement is not written. Okay, number of moles of the ammonia gas, formula is NH3, is equals to, now remember my pyramid here, mass, moles, MR. Okay, so my number of moles is equals to mass over MR. What's the mass? Given the question is 4.5 grams. Now, what is the MR? Okay, where can we find the MR? Is from the periodic table. So let me just do the working at the bottom here. MR of ammonia. Nitrogen is 14 from the periodic table. Hydrogen is 1. How many hydrogen do I have? I have 3. So 3 times 1 equals to 17 when I add that up. Okay, so 17, let me plug it into the formula here, which is 17, 4.5 over 17. Okay, let's punch in our calculator now. 4.5 divided by 17. So you will see a fraction, right? But for my final answer, we have to leave it in decimal place, in decimal to 3 significant figure. So I have 0.2647. Rounded off to 3 significant figure is 0.265. Number of moles units is MOL. Okay, let's try another question. 4.09 moles zinc sulfate. So what am I given is moles. Okay, so I need to find the mass. So using the formula here in the center, the mass of zinc sulfate, formula is ZnSO4, is equals to number of moles times MR. What is number of moles is given the question, 4.09. All right, now what is the MR? Again, we need to find the MR from the periodic table. Okay, zinc is, let me find, it is, if I'm not wrong, is 65. Sulfur is 32. Oxygen is 16. I have 4 oxygen, so I've got to multiply by 4. Okay, so let's punch in our calculator now. 65 plus 32 plus 16 times 4. I got 161. Okay, so let me just plug in the number here, 161 for MR. So 4.09 times 161, punching your calculator, should get 658.49. Okay. Let's always give the full number here first before we round it off to 3 significant figure, which is 658 grams, because we are finding mass. Okay. All right. Now pause your video now. Continue the rest of the practice questions yourself. Okay, and we will discuss the answers in class.